what's the main challenges or limitations for data science teams to implement
Um,
these ML solutions?
'Cause that could be a podcast all by itself. What are the challenges there? But I mean, a lot of the key challenges, not just for data science teams, but for developers in general here. Um, Firstly, is model compression. That you need to get a model really small to run, and that very depends on your device, whether it's on a mobile phone, a Raspberry Pi, a microcontroller. Those are very different things, and because of that, it's also quite difficult to sometimes for the code to actually get the model to run inference. It's not something where normally when you do some sort of development work, especially with AI, you're just working in Python mostly. And for some of these systems, you can't just get it to run on Python. You have to use something like C, C++, or Rust or something like that. And a
Yep.
lot of people who are in ML development don't really know those things, or you have to do work with microcontrollers, embedded systems. And embedded systems engineering isn't not the normal ML ops and AI based
Yeah.
task. And I think that's a huge challenge, but even more considered as a challenge, I think the frameworks. There's a lot of frameworks that come and go. And that's what we saw in the last 10, 12 years with typical machine learning as it's blossomed now. Most people use PyTorch now, and it's become very standard. A lot of people using also Hugging Face on top of PyTorch. And these things are very standardized now. And back 10 years ago, 12 years ago, it wasn't exactly like that. And I think that's where we are now. So there's a lot of frameworks that are slowly starting to come out now. And most people right now, they use TensorFlow Lite for a lot of these things, but it's a bit outdated. And I have heard that PyTorch is coming out with some new stuff there. They actually have released something new. I haven't checked it out myself yet, but I think there are things coming out, but it's a huge bottleneck for us. And I think that's one of the big areas where you have to think about software wise. How do you get your model compressed to run on your device in real time? How do you run the code and get it on the device? How do you test the device in an actual real environment to get it to make sure it works? And how do you do that whole process? And it's a bit harder than regular stuff. I can say that's for sure.
Yeah, sounds a lot more trickier. So,
Yeah, it still is. But hey, like I said, 10, 12 years ago, getting models to run a GPU at all was really hard. And training models back then, in the way we do it now, that it's so much easier, and the tools are so much more standardized. And I think we'll see that too. And there was a huge hype starting a few years ago with deep learning, and then computer vision became very popular before NLP. Although I was working in NLP back then, it wasn't the cool thing it was nowadays. And I think we're seeing the same thing here. We're about 10 or 12 years out. If you look at the time now, how long that'll take to get to the point where we are now with TinyML, that's anyone's guess. But I think we're about like 10, 12 years ago equivalent.
I'm interested. Have you touched on software then? And then